So let us analyze the summation of 2k minus 1 times k squared minus 1 divided by k plus 1 times k squared plus 4 to the second power. K starts from 1 goes to infinity. Okay. It's easier for me to use comparison test here. And compare it with a p-series. What p-series? So when you have polynomials multiplied together divided by some other polynomials, ignore the terms with lower powers. The trick is ignore terms with lower powers. What do I mean by that? So if I write this series, take the general term, my general term on the numerator, ignoring the lower terms. This is 2k minus 1. So I can ignore negative 1 compared to 2k. 2k goes to infinity much more faster than negative 1. Between k squared minus 1, k squared goes to infinity much faster than negative 1. So ignore negative 1. On the denominator, you get k plus 1. Between k and 1, you can basically ignore 1. Why is that? Because k goes to infinity much more faster than 1. Between k squared plus 4, indeed you can ignore 4 because k squared goes to infinity much faster than 4. So now simplify this. Then simplify. If you simplify this guy, this becomes 2k times k squared divided by k times k squared to power 2. You can simplify this further. You get 2k squared divided by k squared times k squared. Ignore k squared. So this guy is simplified into 2 divided by k squared. Hey, I found my p-series. So it is comparable to p-series summation of 1 divided by k squared. Perfect. So let's see what's happening here. 2k minus 1 times k squared minus 1 divided by k plus 1 times k squared plus 4 to power 2 is less than 2k times k squared divided by k times k squared to power 2 that you just showed is equal to 2 divided by k squared. For every k on the domain 1 to positive infinity, this is always true. So let us go back to comparison test. Comparison test tells me if I have an less than equals to bn, and if the larger series is convergent, then the smaller series is convergent as well. So take a look. On the left-hand side, I have this series, original series. On the right-hand side, I have 2 times 1 over k squared, which is basically a p-series. So I can write it as 2 times 1 over k squared, which is a p-series p is equal to 2. P is this quantity here, everyone, the exponent, more than 1. So it is convergent. Based on comparison test, the smaller series must be convergent as well. So the series on the left, which is 2k minus 1 times k squared minus 1 divided by k plus 1 times k squared plus 4 to power 2 is also a convergent series using comparison test. So we just showed that this series, which looks a little bit more complicated than regular series, is a convergent series. So again, as long as you look at these types of series and quickly ignore the terms with lower power or the terms that they go to infinity much slower than the rest of the terms, you can get a p-series, and right away you know how to deal with the p-series. Being less than or more than is all algebra that we are doing. Of course, you have subtraction here. 2k minus 1, k squared minus 1 is always less than 2k times k squared. That's how you end up with less than. If it was plus 1, you get more than everyone. So be careful about algebra. When you're doing the algebra, make sure you know how to follow. 2k minus 1 is less than 2k. 2k minus 1 is less than 2k. K squared minus 1 is also less than k squared. So when you multiply the terms on the left, is less than the multiplication of the terms on the right. So you get 2k minus 1 times k squared minus 1 less than 2k times k squared. And then just divide everything by k plus 1 times k squared plus 4 to power 2 because it's just a positive number. But at the same time, if you do the algebra, you can see that 1 divided by k plus 1 times k squared plus 4 to power 2 is less than 2 divided by k squared. So that's how you can use algebra and show that the series on the left-hand side has general term, which is less than the general term of the series on the right-hand side. That's how you can apply comparison test. So let me write the rest of the things here for you. And this is the test. And we saw that 1 divided by k plus 1, or if you want to write everything from scratch, here you have k plus 1 times k squared plus 4 to power 2 is more than k squared. If you flip this, you get 1 divided by k plus 1 times k squared plus 4 to power 2 is less than 1 over k squared. So then multiply left-hand side together and the right-hand side together, right? You can simplify this further. And instead of k squared, let's just add k times k to the 4th. So when you're doing the multiplication, you see everything right away. So let me just copy everything here. K squared times k to the 4th. So you get k times k to the 4th. Then you do the multiplication and you simplify as you see here. 2 divided by k squared. Multiplication of these two and the multiplication of these two and the inequality stay the same.